Alright, let's look at radian measure next. Okay, so to keep this short, although we know what 1 radian is, it's just the angle measure in the case that the arc measure is the exact same length as the radius. That would be 1 radian. For a full circle, we know that it has, if you went all the way around, it would be 2 pi radians. Okay, so, but for the sake of what you're learning in this class, a majority of what you need to learn is how to convert degrees into radians. How do we do that? Well, we can take the degree and multiply it by pi over 180. It is truly this simple. If you can reduce it, reduce it. I can divide that by 5, right? Top and bottom. I could probably divide it by something even better, but let's take 135 divided by 5. We get 27. The pi remains. And 180 divided by 5 would be 36. And it looks like this reduces again if we divide the top and bottom by 9. So we get 3 pi fourths. So we know 135 degrees is 3 pi fourth radians. Let's try it for degrees of 18 degrees. 18 times pi over 180, which is equal to 18 pi 180ths, which we can then reduce by dividing the top and bottom by 18. We get pi tenths. Okay, pi tenth radians. Let's next convert each angle into the angle that's in radians into degrees. So the difference between converting radians into degrees as opposed to degrees into radians is here we use pi over 180. In this case, we're going to use 180 over pi. So 180 over pi times 7 pi 6. So when we multiply, the pi's cancel, and then we can actually divide the bottom by 6 and the top by 6. What does that give us? We end up with 7 times 30, which is 210, over 1, which is just 210. So 7 pi 6 radians is 210 degrees. Let's try with this one. Again, we're going to multiply this by 180 over pi. These cancel very nicely, and we know that we can divide the bottom by 3, gives us 1, and the top by 3, it gives us 60. So what do we end up with? 60 times 4 is 240. So 4 pi thirds is equal to 240 degrees. And we'll skip that. And then finally, we got into area. So for area, pi r squared. You need to note that, pi r squared, which is different. Pi r squared is clearly different than for arc length where we use 2 pi r. Need to make that difference. I've noticed in a lot of the quizzes people were using 2 pi r or 2 pi r squared and mixing them all up. 2 pi r refers directly just to the perimeter of the circle, okay? But when we're looking at area, you need to use pi r squared. So it's referring to the space within a circle. So imagine you had a circle with a radius of, let's say, 4 feet. we would know the area of the entire circle would be pi times 4 squared. So that would be 16 pi feet. Okay, that would be the entire area. But we've learned about taking parts of the area. For example, with a sector, what you do is you find the area, pi r squared, and then you multiply it by the ratio of the arc measured to the entire circle. So, do we have any? I'll make up a situation here. Let's use the same circle with the same radius, and let's do 120 degrees. This is 120 degrees, so the arc is 120 degrees. So, what is this area right here? Well, again, we're looking at the ratio. So what's taken up? 120 degrees out of the entire 360, and we're just multiplying that by the entire area, which we've already calculated is 16 pi. Now all you have to do is reduce it. 1236 times 16 pi, and we can reduce this again, right? We can divide by 4. Oh, 6 would even be better, huh? 2 sixths. Ooh, 12 would have even been better. So I'm just going to carry on. Divide the top and bottom by 2, we get 1/3 times 16 pi, which finally reduces to 16 pi thirds. Now this is an acceptable answer if the question is asking you for the exact answer or in terms of pi. This is acceptable. Now if it's asking you to round to the nearest tenth or the nearest hundredth, what you'll have to do is actually plug it into your calculator. See if my calculator works here. 16.75. So 16.75 feet. And remember, this is squared. So if you think about it, copy this. If you look at this circle and you consider the fact that, I don't know what happened there. You consider that the entire circle is 16 pi, which is 50, approximately 50 feet squared. That's the entire circle. And you say, oh, well, let's just take 120 degrees out of it. We're taking actually 1/3 of that. So you end up with, and it seems reasonable, right, that you would end up with 16.75 if the entire circle was 50. That's a reasonable answer. Always double check that, okay? Double check that. Area of a segment is the same thing, but you need to subtract out the triangle that exists there, okay? So, show you an example. Let's take this segment here, 90 degrees, and we just want this region right here. We want to know what's the area of this segment. Well, we'll do the same thing as we did for a sector, so find this area. If I told you this was 90 degrees, you would say, okay, so the area of that sector is 90 over 360 times, let's say the radius were 6, times pi 6 squared. So even just getting this is nearly half of the problem. this reduces to 1/4, and 6 squared is 36, so we have this. If you reduce that even more, you get 36 pi fourths, which reduces to 9 pi. So that's the area of the sector. So I'll outline that in gold. That's the area of the sector, 9 pi. But what we really want is the area of this segment. So what we have to do is subtract out this triangle. So the triangle here is height of 6, a base of 6. So we know the area of that triangle is 1/2 base times height. So 1/2 of 36 gives us 18. So this right here is 18 units, which means that little segment, the blue area, is, I'll write that in blue. There we go. Area of the segment is equal to the area of the sector minus the area of that triangle, in which case we know the area of the sector is 9 pi, and we know the area of the triangle is 18. So this would be your answer. If you're asked to round to the nearest tenth, that is when you would plug it into your calculator. And that basically covers everything. Look at all you've learned. That is quite a lot.